Assalamualaikum and hello everyone. Today we would like to present our chosen food product, which is biscuit crackers. Biscuit crackers are popular snack that is crispy, tasty and has a long shelf life. They are produced in a modern factory where raw material like flour, water and salt are carefully mixed, baked in oven, cooled and then packaged. The factory is designed to ensure that the crackers are safe, high quality and hygienic. Each step is controlled to prevent contamination and maintain the right texture and taste. In this video, we will show how hazard analysis, critical control point, system thinking, anticipatory thinking and commitment to sustainability are applied to ensure effective food safety management.
As you can see, this is the flow diagram of biscuit production, showing all steps from raw material receiving until distribution. The critical control points identified in this process include baking, water activity testing, and packaging. Now, we're at the baking stage. This is identified as CCP1. The main hazard is the survival of microorganisms due to insufficient baking temperature and time. The critical limits are temperature of at least 160 degrees Celsius and baking time of 10 to 15 minutes. We monitor this by checking the oven temperature using a temperature gauge and controlling the baking time using a timer for every batch. If the limits are not met, corrective actions include adjusting the oven temperature, extending the baking time, or discarding the affected product. Verification is done by reviewing baking records and all data is recorded in the baking log. For water activity testing, this is CCP2. The hazard is the growth of microorganisms due to high moisture content in the product. The critical limit is water activity of 0.6 or below. Monitoring is done using a water activity meter for every batch by quality control personnel. If the water activity is too high, we will adjust the oven conditions, extend the baking time or reject the batch. Verification is done through calibration of the water activity meter, and results are recorded in the water activity test record. Finally, for the packaging stage, is packaging environment cleanliness. The hazard is dust accumulation, which can cause contamination. The critical limit is no visible dust in the packaging area. Monitoring is done through visual inspection every hour. If contamination is detected, we stop packaging, clean and sanitize the area, and remove affected products. Verification is done through environmental swab testing, and records are kept in the packaging monitoring log.
When we look at the production of a cracker, we aren't just looking at a factory, we are looking at a connected system. Using system thinking, we see that every step from the farm to the store depends on the one before it. If we change one dot, it ripples through the whole chain. When we look at the production of a cracker, we aren't just looking at a... Next is system map and the domino effect. Our system map follows a clear flow. Raw materials go into processing, then packaging, distribution, and finally the consumer. Think of this like dominoes. If our raw materials like the flour have too much moisture because of a humid environment, the processing stage is impacted. The oven can't bake them evenly, leading to soggy crackers. These crackers then fail in packaging because they release moisture in the bag, meaning by the time they reach the consumer, the quality is lost. This is why we must manage the entire system, not just the oven. Next is system map and the domino effect. Our system map follows a clear flow. Raw materials go into processing, then packaging, distribution. FIFO and efficiency. To keep this system healthy, we apply the FIFO principle, first in, first out. This means we ensure the oldest ingredients are used first in the warehouse and the oldest batch are shipped out first during distribution. By doing this, we prevent dead stock where flour or crackers sit too long and go stale. This is the crucial link between storage and quality, ensuring that the consumer always gets a fresh product while we minimize inventory waste. Sustainability and future vision. Finally, we focus on sustainability. We use AI sensors in our ovens to monitor the moisture in real time. This ensures every cracker is baked perfectly for the first time, which saves massive amounts of energy and prevents food waste. We also move toward a closed loop by using compostable packaging and recycling broken crackers into animal feed. By connecting the dots between smart technology, efficient flow like FIFO, and eco-friendly choices, we create a system that is better for the planet and the people. That's all from me.
Next, moving on, we will explore anticipatory thinking and future challenges in biscuit cracker production. One major challenge we may face is climate change. Climate change such as flood and unstable temperature can affect wheat production in major exporting countries like Australia and Canada. Since Malaysia does not produce enough wheat, it relies heavily on import from those countries. This situation may reduce the supply of wheat and affect its quality. As a result, it can impact the texture and the taste of the biscuit crackers. In addition, climate change can lead to unpredictable harvesting season, which directly affect wheat production. This makes it difficult for manufacturers to maintain consistent production planning. Extreme weather conditions may also disrupt global transportation systems, causing delay and importing raw material. And another challenge is the rising cost of raw material due to global conflicts. Malaysians depend a lot on imported wheat from other countries, so if wheat exporting countries are involved in war, they may reduce export and increase the price of the wheat. This means Malaysian has to buy wheat at a higher price. When wheat price go up, the production cost of biscuit crackers also increase. As a result, companies may raise price or reduce the size and quality of their product to keep their profit. In the future, this can affect product price and consumer buying power.
For commitment to sustainability, we focus on adapting to climate change, which can affect the supply of import wheat used in our biscuit crackers. To manage this, we work closely with trust suppliers from countries such as the United States to ensure a stable supply of high-quality wheat. We also store the flour in clean, dry and cool conditions to protect it from the heat and humidity. This helps maintain consistent dough quality, ensuring our biscuit crackers remain crispy and tasty while reducing waste. Due to global conflicts such as the Russia-Ukraine war, the supply of wheat can be disrupted. As a solution which is considered as a long-term solution, Malaysia can explore local wheat cultivation using advanced agricultural technologies. This approach involves not only farmers but also support from research and government, as it requires advanced system and crop development. First, wheat can be grown in controlled environment systems such as greenhouses. In this system, temperature and humidity are controlled using cooling system to create a suitable climate for wheat growth. This is important because wheat requires cooler climate and stable growing conditions, which are not naturally available in Malaysia's tropical environment.
In conclusion, sustainable food quality management is essential to ensure that biscuit crackers remain safe, high quality and consistently produced. By applying HACCP principles, we are able to control potential hazards and ensure food safety at every stage of production. By applying through systems thinking and anticipatory thinking, we can better understand the production process and prepare for future challenges.
We believe that producing safe food today while protecting resources for the future is the key to a sustainable food industry. That's all from us. Thank you.